Okay, so we initially had Malin with Microsoft MVP was supposed to join us today to be doing the presentation, but so unfortunately, Malin had some unforeseen emergencies come up, so he's unable to attend today. So I will be doing the presentation today. So forgive me if the presentation doesn't look as prepared as it should be or as it could be. So because I've just had to put on something together or put something together quickly because Marlene sent me a message I is unable to attend due to some unforeseen emergencies. That being said, we're still going to have a nice time introducing you to the world of containers in Azure. So my name is David Okeode. I'm a cloud solutions architect, cloud security architect. I work with Azure a lot. I'm a Microsoft certified trainer. I'm a triple MCSE. I'm an AWS Solutions Associate Professional. I'm a VMware certified professional and a bunch of other certifications that I've managed to achieve during the course of my career. So today we're going to be talking about containers in Azure. I know this is one of the things that a lot of people coming from the IT pro world can struggle with because it's a new paradigm from what we're used to. We're used to doing things a certain way. We're used to doing things a particular way. And then we have some of these new terms that we've never heard of come and being thrown at us. So we have things like containers, images, Kubernetes, Docker Swarm, Mesosphere, CI/CD, and then we're wondering what all these new terms that's coming out. And sometimes, if you're getting something brand new, so sometimes the reaction that unfortunately some of us may have is to shut down to go, okay, I'm just going to block it out. But we blocking it out doesn't mean it's going to go away. So the actual prediction is in a couple of years to come, majority of enterprise and consumer applications will be running on containers, not the same model that we currently know. So it's important for us to try to learn and see what we can understand when it comes to containers in Azure, which is what we're going to be discussing today. So, where are we going to start? First of all, let's start by understanding what this thing is that we call containers. What exactly are containers? What is this for us? And what I'll do is because I understand that some of the people that I'm speaking with today, you're from you're from a background like myself. This is not your normal world. So let's try to take it back a bit, and I'll try to use something that you can relate to try to explain what containers are. So to begin with, we all knew of the change or the revolution that happened when we had virtual machine hypervisor. I mean, they used to be in years before hypervisor came or virtualization came, we used to have one server to do one purpose. So we'll have one server in our data centers that will say, that is my domain controller, that is my exchange server, that is my DNS server, that is my DHCP server. And it's a physical hardware that we can point to. But then virtualization came, or hardware virtualization came in form of hypervisors, and it changed completely the way that we deploy servers in our environments. The way that we commission servers in our environment completely changed because of hypervisors. So nowadays, if you want to commission servers, it's not going to take you months and weeks or whatever to order a new hardware, to get it racked, to get it cabled, and all that other stuff that you have to do. With a simple click of a few times, a few clicks on VMware vSphere on Microsoft Hyper-V, you have a new virtual machine up and running within a few minutes. Something that you can even automate and make it very quick. So if you think about that revolution that virtual machines brought to the world of servers, the same level of revolution is what containers is bringing to the world of running applications. So it's completely going to it is completely revolutionizing the way that we run applications and changing the entire model. So we'll talk about that a little bit in a minute, and I think I'll show you a quick demo to try to bring home that point of what we get with containers. So first of all, on the left-hand side, you can see here the virtual machine model where we have a host operating system, and then on top of our host operating system, we'll have our hypervisor. And then on top of the hypervisor, we can have a guest operating systems, and then we have the shared libraries of the OS, and then we have our applications running on those. Now you look at the container model on the right-hand side, where the hypervisor essentially is gone. It's not necessarily that it's gone, but let's say the hypervisor is gone in this case. And what we have now is we have the operating system back running on the hardware, but then on top of the operating system, we have this thing called container engine. And that what that means is that we can now have our libraries and our applications running in this thing called containers. Now, so we're using the container engine. And the container engine is responsible for ensuring that we have something called namespace isolation and process isolation, so that one container, can't just begin to use resources allocated to the other container without permission, stuff like that. So ensuring that there's true isolation. As we go on, it will make more sense. So just bear with me a little bit, and it will make more sense as we go on. So let's move on to the next slide. So next slide, let's talk a bit about this thing called Docker. Because every time that we talk about the term containers, inevitably Docker will come up. And Docker, to understand it, is a form of containerization, or it's a form of, they are the leading open source containerization platform. They are not the only one, by the way. There's other containerization platform, but at the moment, the industry is completely dominated by Docker. So Docker is open source, it's Linux based, it's the main thing that we use today, or that we're even going to be talking about today when we're talking about containers. Let's carry on. And as I mentioned earlier, Docker is an open source container runtime. Docker gives us the tools to be able to build our container images, to be able to deploy and run containers, and even to be able to manage and orchestrate containers in the form of Docker Swarm. I know that these terms that I'm mentioning may not make sense to you now, but just follow me and we'll get somewhere. So I made a claim earlier. Before I get to the slide, I made a claim earlier and I mentioned that containers revolutionizing the way we run applications, the same way that virtual machines revolutionize the way we commission servers in our enterprises. Let me show you a bit of demo on that. So the first thing that I will bring out is sometimes I work in IT security, and sometimes I've got to do some penetration testing, labs, and whatever. And I've got to set up this application or this web app called Damn Vulnerable Web Application. So actually, I'll bring this up on the screen here. So I want to set up this app called Damn Vulnerable Web Application. And for me to be able to set up this web app, so the stuff that I need to go through. So if I want to set it up on Azure, first of all, I deploy my Azure VM. That's standard for all of us. Actually, before I move on, let me bring up what's it called? Let's bring up my Azure portal. And let's see if I've got some virtual machines that I can use. Let's go to under my virtual machines. And under my virtual machines, let's go. I'll just create a new resource. I'll create a new Ubuntu machine. So that it's deploying what I'm talking about this. So I'll call this DO Ubuntu 01. Give it a username. Give it a password. And by the way, there's a really cool new feature that Microsoft are bringing out. The ability to log into Linux using Azure AD credentials. So I'll go ahead and click OK to that. I have this Ubuntu virtual machine. And then I'll select a size for my virtual machine. Hopefully that does not take long. So I'll select something smaller, maybe DS1 V2. That'll do. And I'll leave most of this at the default setting. The only thing that I'll change is I'll change the network security group. I'll set this to none just because it's a test environment and this is an environment that'll be completely destroyed immediately after this. Yeah, so once I trigger that and we start running, okay, so now my Ubuntu virtual machine is running, following this step to deploy DVWA, which is Damn Vulnerable Web Application, to Azure so I can do my pen testing labs. So after this is fully deployed, then I'm going to go through stage number 2, which is I SSH into the machine and then look at the next things I need to do. So first of all, all I want to do is I want to be able to run this application to do some pen testing labs. But I've got to start with, does this application have dependencies? Of course it has dependencies. So I need to install PHP and then, okay, I need to install PHP. I need to have the right PHP version to be installed. Right? So I need to go, do I need to install PHP version 5.6, version 7? Which one do I need to install? I need to get the right version of PHP to install. So after installing the right version of PHP, I've got to install the right version of MySQL. So I've got to get that installed. I've got to go make sure that I download and install the right version. Then I've got to go to Git and I'm going to put down the DVWA project from Git. But before I can do that, first of all, I need to install Git. So another dependency. So I've got to take care of that dependency. Sometimes some dependencies have other dependencies called transitive dependencies. So I've got to install other dependencies on that. Then after that, I've got to modify the DVWA settings for my SQL permissions. Then after I do that, I've got to modify some permissions to give Apache privileges to traverse the directory. Then after that, I've got to move my PHP config file. Then after that, I've got to set my Apache server name. Then after that, I've got to configure PHP to enable Apache URL. And after that, I restart Apache. Then I can begin to use my web app. Look at all this process that I've had to go through just because I want to run an application. And look at you, and I'm sure like many of you have faced the same situation where all you want to do is to run a simple app, but by the time you're done, you spend about 5 hours. And I'm not kidding, you spend about 5 hours looking at different documentation, trying to download this prerequisite and the prerequisite to the prerequisite and the prerequisite to the prerequisite of the prerequisite, and then it goes on and on and on, and before you know it, you think you're done. It's going to tell you, man, you need to modify this config file and registry because there's a conflict. So at the moment, the way that we currently do run our applications, it's something that's cumbersome, right? So that's where containers come in. So actually, before I proceed, because this may be another good opportunity to show you the options that we have when talking about containers in Azure. So one of the first options, which I'll get to again in some later slides, is to run containers in Azure, is to just run containers on virtual machines in Azure. So, and the way to do that is, of course, that's the IaaS model, the infrastructure as a service model, which will deploy a virtual machine in Azure. So what I'll do here is I'll go to create a new resource. Actually, I did already. I created an Ubuntu resource earlier, which is my DO Ubuntu 01, the resource that I created. So if I have an existing Ubuntu server in Azure that I want to be able to run Docker containers on it, I can enable the Docker extension to allow me to do that. So I can also specify the extension if it's for an existing virtual machine. So for an existing virtual machine, I can specify the extension here and click on Add, and then look for the Docker extension, which we have here. And once I select the Docker extension and I click on Create, It's going to specify I'm going to install that, and then I can go ahead and load in my CA certificates, my server certificates, and my server key. And that's because of security, because remember that this is going to be available over the internet. So it's going to try to implement TLS to secure the communication between the Docker client and the Docker engine on this one. So we can do that. We can also specify the extension when we're deploying a new machine. So if I want to deploy a new machine, a new Ubuntu machine, when it gets to the stage of specifying, I can specify and add the extension then. But to me, one of my favorites one of my favorites in terms of deploying a virtual machine in Azure that can run Docker hosts, it's just using the Azure Shell or the Azure CLI. It's really straightforward. It's really simple. It's just a few lines. So I actually showed that to you. So we'll let bash load and I'll show that to you how simple and how straightforward that is. So here I am. I'm on the Azure CLI. For those of you that are familiar with this. So on the Azure CLI, I'll run a command. I'll run following command, which is az group create -n, which is short form for the name. And I'll call it do Ubuntu 02 rg for the resource group for that. I specify my location, I'll specify HTUS, and that will create my resource group for me called do Ubuntu-resource group. And then what I'll do is I'll actually just deploy an Azure template that's going to deploy an Ubuntu virtual machine in Azure that has the Docker extension loaded. It's going to generate some self-signed certificate for that. So that's what I'll do now. So I'll go ahead and see if I can copy and paste this to make it much more easier. Yep, that will do. So what I'm doing here is Azure group deployment create. I'm creating an Azure deployment, specifying the resource group. So I need to make a change to that resource group. So let me do Control C. Let's change the resource group to my actual resource group, which I've created here. So let's get that resource group right. Here we go. So what I'll do now is I'll paste that command. Let's do a clear to make the screen more cleaner for us. And I'll go ahead and just run this. Ask me for my username. I put in my username. It's going to ask me for my password. I put in my password. It's going to ask me for the DNS name. I'll say do Ubuntu 02 something unique so that there's no conflict. And then it's just going to run. And then at the end of this deployment, I'll have a virtual machine that I can run Docker containers on in Azure. And I think if this is successful, which I think it will, I will use this again to try to demo to you just the simplicity of using Docker to run application, which is essentially you pull down an image and you run the image in a container. That's all. You don't need to worry about, do I need to go get 10 dependencies to make this to work? That's all gone now. So you can see how this is going to, this changes completely the entire model of running applications and that we're used to. Okay, so let's move on to the other slides for now. Let's go back to this. So while this finishes, we can continue. Okay, so let's talk a little bit about Docker some more. So Docker itself, the architecture of Docker, the two main things that we'll focus on for now, because this is not a deep dive discussion, this is just meant to give us an overview of containers in Azure. So Docker itself, the architecture is we have something called a Docker client, and then we have a Docker engine or Docker. So some people call it the Docker daemon. I call it the Docker engine. So we have the Docker client, we have the Docker daemon or the Docker engine, and you can communicate from your client to the engine. So essentially, you issue commands. So for example, when I pulled down the image, when I typed in the command docker pull, I was typing that command on the Docker client. So when I typed in that command, it's going to it's going to make a request to the Docker engine that's running on my machine. Let's go back. It's going to make a request to the Docker daemon or the Docker engine that's running on my machine. And it's going to make a request to that engine, which is going to go to the Docker Hub, the registry, and pull the image. So that's a public registry. It's going to pull the image that I've specified. And then when I specify Docker run on the client, is going to make make that request to the Docker daemon or Docker engine, which is going to take that image that I've downloaded and deploy it in a container. And then it starts to run. So that's the entire architecture of Docker. And well, it can go more complicated than that. There's more complicated cases, right? But this is just a simplified form of the architecture of Docker. We have a Docker client, we have a Docker host, and the host is running the Docker engine. And then we can have the registry where we're storing our images. So that's the simplified form of this. So in order, for example, to have Docker host installed, which is what I'm currently doing now, um, I can install it, as I mentioned, on the Azure virtual machine using the extension, the VM extension for the Ubuntu machine that I deployed. So that's one option that I have. Another option that I have is to, on a Windows machine, is to download something called Docker for Windows. So let's bring up web browser. Let's do Docker for Windows. And we have Docker for Windows here. And all you have to do is once you download Docker from Windows, once you download it and install it on your machine, you have the Docker engine running on your machine as well as the Docker client to be running on your machine. So you have the client and you have the engine running on your machine, but also you have other things. You have things like the Docker Compose, Docker Swarm, or Docker Machine, sorry, that's going to be running after that. Let's go have a look and see if my deployment is finished now. Oh, it's timed out. Let's go have a look on virtual machines and see if that's finished now. If that's finished, I can try to use that to do the same demo that I was doing before. So that's it. Let's see if that finished. Yeah, it's running now. So I'll click on that. And again, I'll log into it via SSH. I'll close this to avoid confusion. Actually, because I'm not using it and because it's running something vulnerable, do Ubuntu Docker, I'll just stop that. So let's stop that. Okay, let's get SSH going again. So let's go for and okay. So again, I'll try to. I have Docker running on this machine. So if we go Docker help or Docker version will show me the version. You can go Docker help and that will show me all the different commands that I can use, and this is the Docker engine now. So for example, I can manage my Docker configuration if I want to. If I want to see my containers, I can use Docker container and it has other commands, Docker image and it has other commands. So for example, if I do Docker image list, I have no images. If I do Docker container list, I have no containers running. So what I'll do is I'll try to pull down the DVWA image like I did earlier. So let's go ahead and do that. So to do that, I'll use docker pull command, which is docker pull, and I specify the image. By the way, if you're wondering where is this image coming from, it's coming from, by default, it's coming from something called Docker Hub, which is kind of like, if you're familiar with GitHub, it's kind of like GitHub for containers. So with Docker Hub, you can essentially search for whatever image that you're looking for. It's going to show you so people can have their own image. You can see the amount of pulls and stuff. And these are things that you can just pull and begin to run within seconds. right? It's amazing. I tell you, it's absolutely amazing. You can see different ones for different SQLs and different images that you can pull down and begin to use. And also, if you're an enterprise and you want your own private image, where you can host your private images. You can use Azure Container Registry to host your private images. But we'll talk about that a bit later. So Docker pull info slash dvw here, and that will begin to pull that image down. So what it's going to do is it's going to check my machine initially, check on my machine if that image exists. If the image exists on my machine, it's going to compare if I have the latest version of that image. If I don't have the latest version of that image, it's going to reach out to Docker Hub and then it's going to pull down the latest version of the image. If I've configured a private registry, private container registry, it's going to reach out to that private container registry and download the latest version of that image, which is what you do as an enterprise. So now that I've downloaded the image, if I do a Docker image list, I can see that I have my image there and it tells me that I've got the latest version of this image. It gives me the image ID and the size of the image. So the next thing that I want to do is I want to run this. But before I run it again, second time that we're trying, let's ensure that I have no network security group associated with that virtual machine. So let's go Docker VM. If I go under my networking, and I have no security group, so I think that should be okay. So let's go ahead and run that. And that's done. If I do Docker container list now, I can see my container is running. And here's the thing is that if this is working in truth, let's go get my public IP again. And now what I'll do is I'll do HTTP to my public IP address. Hopefully I don't have a space there. And look at that. I mean, that's very much simpler, right? If I go ahead and click create database, it's going to create a database and says, hey, I've created a database. I click login. I'm ready to do my pen testing. I can log into this. I'm logged into it directly. I can begin to do my pen testing. Then you see how easy that is compared with this, right? Compared with going step by step by step. And here's one of the other advantages of this is, oh, by the way, because this is again, because it's vulnerable, I can go ahead and shut this down now, because at least we've seen how that works. So because of this, the same process that I used to deploy this on Linux is the same process that I will use to deploy it on Windows or on a Mac, because they are running on a container engine. If I go to a Windows machine that I have the container engine installed on, fine, no problems. All I'm going to do is I'm going to download the image, I'm going to run the image, and I can begin to use my application. I go on a different machine, download my image, run my image, no need to run around looking for 15 or 500 dependencies and that. Okay, so that's Docker in brief. So quick Docker terms, we have the Docker image. Docker image is actually a prepackaged application that contains not only the application but the application libraries. So that's something that some people may confuse with one another. Sometimes people may confuse Docker image for Docker container. The image is the actual application that our developers will start packaging now. So they will package Docker images and release that. So for example, if I go to this URL again, if I search for Microsoft Microsoft SQL Docker image, Microsoft have packaged a Docker image for SQL Server 2017. And all I need to do, I mean, if you've ever had to deal with the complication of installing, Microsoft SQL, look at this. All you need to do is again, you pull the image, and then once you pull the image, you run the image. Look at that, right? As simple as that. You don't need to go through like all those crazy stuff that we used to do before. Pull the image, run the image. Consistent, no matter the platform that you're running in. Your application is ready within seconds, and it's all good. So yeah, that's our Docker image, right? That's what our our developers will provide into us at the end of that. And then we have the containers, which is what will actually run the image. So our images will run within our containers. Docker file is a type of file that you can use to build images. So if you're kind of like a developer that build images, so you can use Docker file in combination with Docker build. So once you create your Docker file that defines the image, and then with the combination with Docker build, you can build your image that now you can distribute. Then we can also install Docker for Windows, as I mentioned earlier on. Go to the website, search for Docker for Windows. It's going to install the Docker client, Docker engine, Docker Compose, Docker machine, which is something that can be very useful if you want to do Azure administration. It can allow you to connect directly to an Azure machine via a Docker command line on your machine. So it's some very good stuff. Actually, Docker machine can be used to provision a Docker host, a machine that you can run Docker containers on Azure from within Docker machine. So it's very good stuff. So again, these are just some terms for us to be familiar with. Let's move on quickly. Okay, so we've already talked a bit about this, about containers, and that's essentially the technology that containers use. They use technology of namespaces and C groups. And in terms of namespaces, we have what a process can see, and C groups define what a process can use. And it uses a combination of these to ensure that each container is isolated. So that's what it uses to ensure that. And we've already seen some of the Docker CLI, which again, that's like the Docker client. Okay, um, we've seen some of the command lines where I can do Docker help. If you need help to understand the command line, just run Docker help. It shows you what the options are for running those. And you can see some of the options. Docker run, you can use that to run a container. Docker pull to pull an image from the registry. Docker build, if you're building an image. Docker images will list existing images on the machine to you. Docker PS will list running Docker containers, and Docker exec will execute a command within a container, and Docker stop will stop a running container. So these are just basic commands or command commands that we can use. So enough being said, let's talk a little bit about container orchestration, because now this container thing, at least we understand some of the benefits and the usefulness. But in terms of using this in an enterprise, what are some of the things that needs to be in place before we can use this in an enterprise? So for example, compare this to what I talked about earlier with VMware vSphere or Hyper-V and the way that that's changed the world of server commissioning in an enterprise. But the thing is, VMware vSphere by itself is lacking some of the capabilities needed to be able to depend on virtual machines in an enterprise. So for example, if all you have is a single VMware vSphere host and you're running your virtual machine, what happens if that host fails, right? That's that you've got to do better than that. So what you need to do then is you need to implement VMware vSphere alongside with something called VMware vCenter. And what VMware vCenter will provide is it will provide overall management and features so that you can cluster together, for example, multiple VMware hosts. And if one of your hosts goes down, VMware vCenter will ensure that your virtual machines that were running on the down host are restarted on existing hosts or healthy hosts so that you don't have to take care of that process anymore. So that's what you do. So in the container world, what takes care of that extra management and provide extra stability for us is something called container orchestration. And there are different solutions. So we have things like this is where Kubernetes comes in. Kubernetes is for container orchestration. So just think about it as VMware vCenter for containers. So it's a container orchestration solution. There are other container orchestration solutions like Docker Swarm. So Docker have their own. There's also Mesosphere, DCOS, Data Center Operating System. So element of orchestration, you want something that can handle things like scheduling, things like Affinity to say, this container should not run on the same um, host as this container. I want them to run on different hosts. So you can specify Affinity, anti-Affinity. You can monitor the health of your Docker hosts so that if one of them is unhealthy, the container orchestration solution will ensure that those containers that we're running on those are started on other containers. Ensure that you can scale easily ensure that networking is kept up to date. So maybe you have a bunch of containers providing the same service, ensuring that networking is aligned across all of them. Service discovery, coordinated app upgrades, automatic failover. So these are some of the elements that orchestration provides. And by far, Kubernetes is the de facto orchestrator for containers. Again, remember I said it's not the only orchestrator, but it's kind of like the most popular one, the most popular orchestrator for containers. So as shown here, it provides things like self-healing, automatic placement, automatic restart, automatic replication, automatic scaling. So Kubernetes can detect, oh, the load is getting too high for the number of containers in Kubernetes world, they are called pods. So I won't go into all that because again, this is not to go deep dive into that, but it's going to detect and go, okay, you're running out of resources that's needed. So I'm going to start up or create more pods to get this done and stuff like that. So let's move on beyond this. So Kubernetes is an open source container orchestrator that automates deployment, scaling, and management of your applications. So it provides all these features similar to like what I mentioned, what VMware vCenter will provide to your VMware host. So some of the things that it provides are things like agility, provides agility to our containers, right? So for you, as far as you're concerned, or as far as what Kubernetes will do, it is going to abstract the servers that are running your containers from you. All you know is that you are running your containers. You know, whichever server they're running on is none of your business, right? Okay, Kubernetes will take care of all of that. Scalability also. So Kubernetes can automatically detect that more needs to be added, and it's going to automatically start adding more pods, as they are called in Kubernetes world. But let's just say containers for now. It's going to add more containers for you, and then spread it out across like the server, depending on whatever you've configured. It can also provide reliability. What happens if some of your underlying Docker hosts, the hosts that run in your containers, what happens if they fail? No problems. You won't even notice because Kubernetes can automatically start them up on other LD hosts. So it's a really good one. So finally, let's talk about this, which is what are some of the container options that we have? Because let's tie all this together. We have our containers, we have a container orchestration. Let's tie all this together into this world of Azure. What are the container options that we have in Azure? So you can see number one on your screen, and this is not in any perfect order. We have Azure Kubernetes Service, AKS. So for those that are familiar, you may be thinking, there used to be something called Azure Container Service. There's still Azure Container Service, but I'll probably talk a little bit about that before we finish today. We have the Azure Container Instances. We'll talk a bit about some of these. Azure Container Registry, Azure Service Fabric Cluster, WebApp for containers in Azure, Docker on Ubuntu Server. So these are some of the options for running containers in Azure. Let's look at some of them. We'll demo some of them. We won't demo all of them, but we just look at some of them and touch on them. So number one, Docker on Ubuntu Windows Server. So this is exactly the one that I demoed to you earlier. This is infrastructure as a service model. So what you do is you have, oh, sorry, by the way, this is wrong. I need to modify this. I need to cancel the Windows Server. It's Docker on Ubuntu Server. So cancel the Windows Server part, please. Just ignore that to as if it does not exist. You did not see that. So Docker on Ubuntu Server. So you have the infrastructure as a service model. Azure Docker Virtual Machine extension to install the Docker daemon. So I showed you that earlier, where as you're deploying your new Ubuntu machine in Azure, you can specify and add the Docker extension, and it's going to install the Docker daemon or the Docker engine on that virtual machine. And then you can now begin to run your containers and pull images and run your containers on that virtual machine. So you can tell, it has the downfalls of infrastructure as a service model. Now you have more management work to do. You have to manage the underlying operating system. And also, by default, it does not have any orchestration. So you have a single host that you can run containers on. Fine. What happens if you have a second host? Then you have to have some form of orchestration, and then you've got to maybe set up your own Kubernetes cluster, or if you want to. So it has those downfalls of infrastructure as a service. But nevertheless, it's an option. Actually, if you're new to the container world, this is one of the the good ways to get used to containers and on all that. So by all means, so I've already demoed that. I won't demo that again. So the other option that we have is we have WebApp for containers. So this is where I'll go back to the Azure portal. For WebApp containers, so if I go to create a new resource, and what I'll do is I'll go on I can click on WebApp there. So I'm creating a new WebApp in Azure. I'll call it do docker 01. I'll do do docker 01. I'll put it in the new resource group, do docker 01 how-g. And now you can see the operating system. I can either specify the backend of Windows to be Linux, or I can specify I want to run containers, which you can specify. So you see the difference. If I specify Windows, it gives me, after I deploy it, it can give me the option to configure my middleware, my runtime. Linux, I also have options to specify what my runtime would be and all that. But when I specify Docker, it gives me the option to specify my container. So in this case, I can just go, and similar to what I did earlier, I'm just going to specify the container that I want to run. And it's going to go pull that container. So I can specify the repository. So this is where I can specify if I'm using Docker Hub. So you can see I can specify the source of the image. So I can specify Azure Container Registry, which is a private registry. So you can deploy your container image registry in Azure, and Azure will manage that for you, but it's private. You can specify Docker Hub, which, as I mentioned, is GitHub for Docker or for Docker containers, or sorry, for Docker images. Private registry, which is if you have another private registry that's not Azure Container Registry, you can specify that as your image source. You specify the repository access. If it's private, you need to specify other credentials to be able to access it. So if you're using Azure Container Registry, you need to specify the username and the password of your Azure Container Registry to be able to download this image and run it on your web app, on your app service. I'll specify public in this case because I'm just getting it from Docker Hub, and I'll specify my image, the info/dvwa, and I'll click OK. So this is one option that we have. But one of the things that I want you to notice is that this option, Web App for Containers, it's only for container-based web apps. The key point I want you to make note of is web apps. So this is not for other types of applications, because again, it's for web it's for web application. Azure App Services for web application. It's not for your SQL image to run, or whatever other image that you have that's running whatever other application. It's for web-based applications to run. And it's using the platform as a service model, because Azure App Services platform as a service model. As we saw, it has integration with Docker Hub or with the private Azure Container Registry, or even with any private container registry that you may be using. So by the way, let's go have a look. My deployment, and I've specified that. I click on create. It's going to go ahead and begin the validation with successful, and then it's going to begin the deployment. So I'll leave this. I'll come back to it once it's done. And then you see that again, once it's done, I'll be able to access straight into DVWA without having to worry about any dependencies or anything like that. It's just running as a container image. That's all. So let's move on. We'll come back to check out that demo afterwards. Oh, so now we talk about Azure Kubernetes Services, another option. So when we talk about Azure Kubernetes Service, think about it as a managed Kubernetes environment in Azure. What do we mean by that? All we need to do is we'll just specify and say we want to create a Kubernetes cluster in Azure. We specify the number of underlying hosts that it's going to have. Those are the nodes that will be running our containers. And Azure will take care of the rest. I don't have to deploy the operating system and download Kubernetes and deploy Kubernetes and install Docker on the host. Azure takes care of all of that. So in other words, it's managed Kubernetes services in Azure, fully managed Kubernetes services in Azure. You don't have to do the management of the Kubernetes cluster. You just have to specify and deploy, and Azure takes care of the rest. And then you can begin to run your container, your containers with your images running in them. So I'll do a demo of this one also because it's actually very straightforward one to do. By the way, this is a platform as a service model also. So let me just get into this one for the demo, and then I can move on. So let's go to Azure portal again. Let's check if this one has finished. So this has finished now, right? Look at that. It's finished deploying. So I can go under my Docker resource. Oh, sorry, my web app service resource. And again, I can click on the link. It may take a while to really open, but just give it a while because sometimes after it's finished deploying, it's still doing some processes. Let's go and let's reconnect that. Let's try this in a different page. Let's go. Oh, okay. Let's go copy this. There we go. Again, just give it a while. It's doing some processes in the backend. So while it's doing that processes, we have our Azure Cloud Shell here. Let's create a Azure Kubernetes Services. By the way, if you want to do it from the Azure portal, it's very straightforward to do. You go to create a resource, and under create a resource, you can go under containers, and here we have Azure Kubernetes Services here that we can click on to create. So if I click on Azure Kubernetes Services, I'll show you from the portal, but then I'll just show you from the portal, but then I'll actually do it from the Azure CLI. So here I can specify, create a new resource group for it, specify the resource group name, specify the cluster name, specify the Kubernetes version. So you can see where this is a platform as a service, right? I just specify the version of Kubernetes that I want to be running, and then I specify how many Docker hosts will it create in the backend. I specify how many Docker hosts that I want to run. Can run 4, 6, whatever. Probably start. I think it defaults to 3. It recommends 3 for resiliency. So that's the recommended least number of nodes for resiliency that's needed. So I specify the number of nodes that I want in my cluster, and I click review and create, and that's it. It's going to create that. And I don't need to manage the operating system or whatever. If there's a new version of Kubernetes that comes out, I just click on upgrade and change the version to the latest version. It's going to take care of all that. I don't need to be responsible for all the upgrades. So this is how you do this from the Azure portal. The other thing that I wanted to mention, because this may confuse some of you, is that we have this thing called Azure Kubernetes Cluster, AKS. But if I go under create a resource, there's also something called Azure Container Services. Azure Container Services, which is different. Or maybe not, I'll just go Container Service. There we go. That's Container Service. So Container Service existed before Azure Kubernetes Service came. Container Service, it does similar, it does exactly what Azure Kubernetes Service does. The main difference is Azure Container Service supports or allows support for other orchestration solutions. So if I do do ACS 01, I won't actually go through to create it. I just want to show you some demo provider configuration. So here I can specify different orchestrator apart from Kubernetes. I can specify DCOS, I can specify Swarm, Docker Swarm, which is the orchestration solution provided by Docker themselves. But I can also specify Kubernetes. If you deploy a managed Kubernetes cluster using Azure Container Service, you can see that it's more complicated. There are a number of things that you need to provide to get this to work. It's more complicated than if you do it using Azure Kubernetes Services. So that's the main difference. So you can also create a Kubernetes cluster in Azure using Azure Container Services, but it's more complicated. So because Kubernetes is far more popular, what Microsoft have done is they've taken this and they've simplified it And Azure Kubernetes Services is what you want to use going forward if you're deploying a Kubernetes cluster. So by the way, look at that. My web app is ready. And again, just think about the ease of this in terms of running application. If I go create and reset my database, it's created my database. And again, I can begin to log into this and instantly I can start my pen testing. So that's amazing if you ask me. So again, I'll go under resource group and I'll destroy some of these resource groups before going forward. By the way, if anybody has any question, can you type in the chat window before I move on? I've been talking for a while now. Let's get rid of some of the stuff I created. Um, any question you can put in the chat window and I'll see that. Oh, by the way, let's go back to app services. Let's go check the resource group that I created this in. So what's my resource group? Here we go, do docker 01. Let's go to the resource group and let's destroy this. Okay, so while that's destroying, back to the Azure Cloud Shell, I'll reconnect to that and I'll create my Kubernetes cluster from the command line rather than using the portal. So AZ group create Azure K8SRG. So that's just creating my resource group and specifying the location for my resource group. Go ahead and press enter. And after that, I can create using this command. Now look at how simple that is. Just using that single one line, right? Using that single one line, I've begun the creation of a Kubernetes cluster in Azure. Just that single one line. And at the end of this, I'll have a Kubernetes cluster that has a minimum of 3 Docker hosts that I can deploy my containers on. It's amazing. So you can see Azure AKS install CLI, download the client. So Azure AKS gets credentials. You can use that to get your credentials. You can use the kubectl get nodes. So for those that are familiar with Kubernetes, that is a Kubernetes command line. You can use the Kubernetes command line to actually view what's going on. So you can see that this is why this is platform as a service, because you have some level of visibility to the underlying hosts that are orchestrated or managed by Kubernetes. So I think where I probably stop today is because I've run out of this is there's the Azure Container Instances. So Azure Container Instances, think about it as the serverless model for containers. So it's per you pay per use, which is not the same as platform as a service, which is you pay for the resources and the VMs that you are created. In this case, it's not the same. So let's go back. So it's different in terms of how it's going to bill you. So Azure Container Instances is different in that sense, in terms of how the billing works. Let me show that to you on the page here where that's running. Let's go to Azure Container Instances. So this one has a even higher level of abstraction in the sense of you don't even have visibility into the underlying infrastructure. All you know is that you can bring your containers and run them. So think about it as Azure functions. So whenever you're deploying your Azure web app, you can either deploy it on the virtual machine, infrastructure as a service, platform as a service with Azure App Service, or Azure Function, which is you just bring your code, execute your code, and you pay per second. You pay per second of when your code is actually executing. So that's what Azure Container Instances provides to us. So it's amazing. So that being said, I think the final one that I'll just touch on, which again I won't, because of time, won't be able to demo in full, is something called Azure Container Registry. Let's just go Container Registry. So Container Registries, and this is a solution by Microsoft that allows you to have your own private container registry. So a location where you can upload your images and point your Docker clients to download images from this. Also private images, you have to provide a credential to log into this. So whenever you set one up, it's going to have a password, and then you provide that credential to that. So if I do do ACR01, so let's go do, or let's just go ACR01. Okay, I can't use hyphen, so let's just do ACR01. Let's do do. That will do, hopefully. Yeah, here we go. So, and you can see it has to be unique in this DNS namespace, and then I can specify a resource group for that. And admin user, so if you want it to be private, you probably want to you can enable an admin. So actually, you know what, this is an interesting one to point out. If enabled, you can use the registry name as your username and admin user access key as password. So if you click admin user as you enable this, what that means is the name of the registry, that will be the username, and then it will ask you to specify a password. You can specify the skill for what you want. So all of the skills, either standard, basic, or premium, they provide the same programmatic capabilities. So all you're going to get if you use a higher skill is you get more performance and more skill. But in terms of capabilities, they are all the same. So in this case, I will select basic and I'll click create, and I'll create an Azure Container Registry for me where I can now begin to upload my private container images to. So I think that's probably it for today. Any questions at all? I'm happy to take any questions. So if you have any questions, please feel free to put and type in the chat window, and I'll be happy to take the question and answer that. So everybody's on mute due to the incident that we had the last time. So so unfortunately, some people messed it up. So we had to put everyone on mute. But you can use the chat window, and I'll be happy to answer any questions. Okay, somebody asked and says, can we run containers on Windows virtual machines in Azure? The answer is yes, you can. So you can run containers. Actually, there is a benefit to using a Windows VM. So as long as you install Docker for Windows on your Windows VM, you can run containers on that. Now with Windows, there are two models of containerization. So you can either use the option where they all share the same kernel, which is the same one that we've been using with Linux, or you can use an option where they have isolated kernels, which is called Hyper-V containers. If you want to do that in Azure, you have to ensure that you use one of the V3 virtual machine sizes or virtual machine types, because that allows for nested virtualization, which allows you to run Hyper-V containers. Also, you can run Windows-based containers on Windows VMs. You can run Linux-based containers on Windows VM due to the Bash subshell that's available in Windows. And even if Bash subshell is not available, I think it can even run Linux in a Hyper-V virtual machine. Don't quote me on that, but I think it can, and then allowing you to run Linux containers on Windows. But for now, you cannot run Windows-based containers on Linux. So you can only run Windows-based containers on Windows, not on Linux. But you can run Linux-based containers on Windows. Any other question? Let's say we have two containers on the same VM. How do you differentiate which containers you want to access? So you essentially, my guess would be when you're saying two containers on the same VM, because containers themselves, they're isolated from one another. So remember that when I ran the command to set up my container, I essentially specified the ports that I want to forward. So when I run this, let me bring up, let's bring up, let me see if I still have this. Oh, here we go. So if you look at this, I ran docker run and I specified this. I specify redirect port 80 on the host to port 80 on this container. So I specified that when I ran, or when I specify the command to run that image in the container. specify run this image in the container, but also redirect port 80 of my host to port 80 on this. So that is port redirection. So if you have another one that's running on the same one and you want to provide ports, what's the name? A web service form, you probably need to redirect port 81 to port 80 on that so that you can access it. Does that answer your question? Well, exactly. It's just a matter of port redirection. But again, remember that this is for your own test environment. In an enterprise environment, when you're doing this, you probably want to have something more sophisticated, like again, orchestrator like Kubernetes, because then you can do much more advanced stuff in terms of the networking. And actually, Azure Container Instances allow you to deploy into a VNet, I think. Again, don't quote me on that. So, yeah, does that answer your question, Leon? Is that good? Any other questions? No problems, Leon. Any other questions before we call it a day? By the way, before we go, let me just quickly show you if it's finished deploying the Azure Kubernetes service. So if I go under all services here, and if I type in Kubernetes, I have Kubernetes service here. And there you go, that's my Kubernetes cluster. If I click on that, I can see I currently have 3 cores and 10.5 gig of memory available to this cluster. I can see the version I'm running. If there's a new version of Kubernetes and I want to upgrade to that, I'm currently running the latest version, but it's a matter of clicking the drop down, changing to the latest version. So you see how easy that is. So this is managed Kubernetes cluster. In terms of the scale, I currently have 3 CPUs and 10.5 gig. If I wanted to, it's still creating so I can drag it. But if I wanted to, I could easily drag this and add more hosts to the Kubernetes cluster. Just imagine that you're able to drag something like this to add more VMware hosts to your cluster. So that's essentially what you're doing there. You're adding more hosts to your Kubernetes cluster that you can run containers on. If I go under health here, which is where you can even have more visibility into the host and what's going on. You can see the hosts, the actual hosts that are going to be running your containers. It's going to show you what the agents are doing, and you can see if they are okay or not. You can have a look here at the controllers and the controller services, the services that Kubernetes itself is using to provide the orchestration capabilities. And you can see the containers and have visibility into the health of that. So this is awesome. Okay, with that being said, any other question? Thanks very much for joining this Hangout. I will be posting on LinkedIn, on WhatsApp, and on Twitter, and also on our Google Plus page, different titles that we can vote on. So if you can please just look out for those. Once I release them, what you need to do is just select the next topic that you want us to present on. So hopefully we'll have a Microsoft MVP doing the next presentation. So just vote on the topic that you want us to present on, and then what we'll do is we'll put that together, and that will be our next topic. So the highest number of votes wins. So any interesting topic that you want to see, send those over to me, and then we can put them up for a vote. And if enough people vote for them, that's what we'll do in our next Hangout. Thanks very much again, and see you in the next one. Have a nice day, evening, afternoon. Bye for now.